Hello friends, we have started the tachometric surveying. What are the basic principle of tachometric and what it mean? It is a fast reading methodology, and it is one of the indirect method which can avoid the usage of chain or tape. And in that we have seen about the Stadia method and the tangential method. There are two methods. What is Stadia method? How it works? How it avoids the usage of a chain? For that we have to first understand the principle of Stadia method, right? Already I have explained about what is Stadia. The crosshair which we shown in the objective lens, which contains of 3 wires, top, middle, bottom. The distance between those things we are going to utilize it, right? Based on that, see, the Stadia method is based on the principle that the ratio of the perpendicular to the base is constant in similar isosceles triangle. I hope everybody remember what is isosceles triangle, right? Two sides predominantly will be equal and one base will be different from the two sides, right? So based on that principle, the ratio of the perpendicular to the base is constant, right? This is going to be utilized in this Stadia method. Already we have explained about the crosshair and how it cut the reading in the leveling staff. It is a particular in particular position. When the staff is hold, we get focus about 3 readings. When the distance of the staff get varied, when it is close, it may be look like this. It may be go beyond and beyond, right? So this is the thing. When the staff at closer, it may look like this, or first it may look like this. When we get closer, it may vary, right? But the center line of sight will be at constant level in all the position of the staff, but the distance varies, right? And the top and the bottom will keep on increasing from closer to the farer, or from farer to the closer it keep on decreasing, but in a constant ratio, right? So this is the principle we are try to utilize it. It is already available, we try to utilize it. And this O is the optical center of the telescope, right? And based on this magnification angle only, the intercepts will get vary, right? So in the figure, let two rays OA and OB be equally inclined to the central ray OC, OA, OB. Let A2 B2, A1 B1 and AB be the staff intercept. AB is one staff intercept, A1 B1 one staff intercept, and A2 B2 is another staff intercept. Evidently, so based on the principle of isosceles triangle, OC2 by A2 B2 must be equal to OC1 by A1 B1 must be equal to OC by AB. The ratio of all these 3 will be equal. That is the principle of isosceles triangle. So it is a look like a constant. So it can be represented based on the triangle. If you apply one half of the right angle triangle, then the beta becomes beta by 2, right? So if we require a particular staff intercept, say it is 1 half and another is 1 half, it is 2. So what we try to determine in the half of the right angle triangle is half, right? So here they have used cot. You can even say tan beta by 2 is equal to what? Opposite it is 1 by this distance OC, right? So if it is we required 2 times 2 tan beta by 2, right? That's it. If you represent in the cot, it is half cot beta by 2. That's it. So this constant k entirely depends upon the magnitude of the angle B. This you have to understood, right? If the angle varies for a particular instrument, the ratio value, the constant value also get varied, right? In actual practice, observation may be made with either horizontal line of sight or with inclined line of sight. In the later case, predominantly the telescope will be, if you hold 0 0 in the vernier C and D, it look like a dumpy level. When we shift the telescope either upward or downward, it becomes an inclined line of sight, right? In the later case, the staff may be kept either vertically or normal to the line of sight. Before understanding that, we have to determine first the distance elevation formula for the horizontal sight should be derived, right? That we will see now. What is horizontal sight? So this principle, this diagram you have to understood, right? Say this is our eyepiece end, right, where the object get focused, and from here we try to see the object, and this is the lens where the objective end try to get the external staff and get focused here, and it get transferred to the eyepiece end. And this is the point you have to remember, that is the exact vertical axis which drop to the ground as a station point. So this is the instrument center, this is the optical center. So O and M you have to remember, and from the eyepiece end, and this is the staff where it get hold, it is a staff. So the point A, B, C get focused in that eyepiece center A, C, B. So the difference between the top to the bottom at the staff end is denoted by S, that is called as staff intercept, and the difference between here A to B, it is represented as a small I, and it is called as Stadia intercept I, right? And the distance between the optical center to the staff, it is called as F1, and optical center to the eyepiece end, it is called as F2. In the physics you may remember, it may be represented by U and V, right? And the distance between the instrument to the staff, it is capital D, the required distance to be determined, but there is an objective lens to the instrument center, that distance is represented by small d. These are the parts you have to remember. If you are not able, please pause and see back. Consider the figure what I have explained here. It is going to show in which O is the optical center of the objective of an external focusing telescope. Let ACB, the points cut by three lines of sight corresponding to 3 wires. B, C and A, top axial and bottom halves of the diaphragm. Small AB is represented by I, the interval between the stadia has, that is stadia interval. ABS is staff intercept. F is the focal length of the objective entire instrument. How it can be obtained, we can see one by one. The same figure in miniature I have tried to show here. You should remember this. So the F1, horizontal distance of the staff from the optical center of the objective. F2, horizontal distance of the cross wire from O. Small d, distance of the vertical axis of the instrument from O. and the capital D, the horizontal distance of the staff from the vertical axis of the instrument, and M is the center of the instrument corresponding to the vertical axis. Since the rays BOB and BOB, sorry, the ray BOB and AOA pass through the optical center O, they are straight, so that triangle AOB and small AOB are similar triangles. So the similar triangle principle, we can utilize it, right? Therefore F1 by F2 must be equal to S by I, right? So these focal length ratio must be equal to the interval, staff intercept and the stadia intercept ratio. Again, by the length formula, you may remember the focal length 1 by F is equal to 1 by F2 plus 1 by F1. This you have already studied in the physics. So multiplying throughout in this equation, try to multiply F1 in the numerator. What you will get? If you substitute F1, F get cancelled, F1 will be there. If you multiply here F into, there will be F1 by F2 plus, here if you substitute the F1 by F1 get cancelled, the F will be left out. So the F1 by F2, here we can replace it by S by I, right? So substituting the value of F1 by F2 is equal to S by I in the above equation, we get, so F1 is equal to S by I into F plus F, right? So the horizontal distance what we actually required is from the instrument center to the staff, the capital D is the required, right? So the horizontal distance between the axis and the staff, capital D, can be represented by F1 plus small d, right? So the F1 plus small d. What is F1? We have obtained here. You can substitute this value here, right? So the capital D is equal to, instead of F1 we are substituting the S by I into F, we can rearrange as F by I into S plus, already F is available, plus D, right? So see, in this we require D unknown, the S is staff intercept. This will vary based on the position of the staff, so it is a variable constant, right? But it will be constant for the particular time, but the focal length of the instrument won't get changed. The stadia intercept, this I also won't get changed. So these are all constant, and this distance from the objective to the instrument center, this distance also won't get vary. So here we are grouping all the constant, and this is variable constant. So the F by I can be replaced as K, and F plus D can be replaced by C. So the K and C are the constant, and S is the variable constant, right? Again, this K and C are called as, since it is F plus D is additive, so C is called as additive constant, and F by I it is called as a multiplicative constant. It should be a dividative constant, but we won't say as a dividative constant predominantly, so it is called as multiplicative constant. F by I as represented K, so the K is called as multiplicative constant and C is called as a additive constant. So the distance, horizontal distance in the horizontal line of sight, we can obtain capital D is equal to K S plus C. I hope you have understood, right? Thank you, friends.